I was able to evaluate a large reader study, and I was able to look at how they scored lesions and how they classified them with BI-RADS. And I was able to do an analysis of false negatives and what caused them, and then what we might be able to do to minimize them. And by false negatives, I mean underclassification in terms of BI-RADS category for the percentage of cases that turned out to malignancy. So basically, because we all perceive that the cost of a false negative is greater than the cost of a false positive, and we correctly perceive that, we've developed an algorithm for interpreting images in which we can achieve 98% or greater sensitivity. But that comes at the cost of false positives. So in the United States, body-breast hybrids, people who are body imagers who also cross-cover their partners in breast, tend to have about 4 false positives for every true positive. So they have a true positive rate of only 20%. Dedicated breast imagers tend to have true positive rates somewhere in the 30 to 40% range. But you know, even for dedicated breast imagers, that means that in general we're getting 2 out of 3 negative biopsies for every positive, and for non-dedicated breast imagers, like 4 out of 5 negative. But we've learned to live with these false positives. Now, we all recognize that the cost of a false negative is much higher than the cost of false positive. So, you know, we really tune our algorithms to achieve adequate sensitivity. But even doing that, we can get false negatives. So when I think about false negatives, I classify them in 2 ways. Absolute false negatives, which are cases that we call BI-RADS 3 and suggest the possibility of follow-up rather than biopsy, that turn out to be malignant. But there's also relative false negatives. And what's a relative false negative? Well, that's where we underclassify a lesion. We may call it 4A when it's really 4B or C. Now, in ACR BI-RADS edition 5, you need 3 things in order to call a lesion benign. You need oval shape, parallel orientation, and well-circumscribed margins. That sounds really simple. What could possibly go wrong, right? Well, a lot can go wrong. So what did I find went wrong with these BI-RADS 3 classifications? Well, how did the readers do overall? There were 66 false negative reads out of 12,289 total reads. You know, that's a pretty good false negative rate. That's less than 2%. So did the readers overall achieve the ACR BI-RADS false negative rate of less than or equal to 2% for BI-RADS 3? They did. But that doesn't mean we can't learn something from the false negatives that they had. So I did a very intense evaluation of these 66 cases to see how they managed to get underclassified. I also was a reader, and so there were 1,757 masses. I read these as a blinded reader just like the other readers did. So I used myself as a reference standard to see how they scored and classified differently from them, to get an idea of how I might be able to teach people to do better and how to minimize false negatives in BI-RADS 3. So the top 3 causes of false negatives were the readers were too loose on the definition of oval shaped. I looked at what the readers were calling oval shaped and I said, how in the world can you call that oval? That is irregular as all get out. And so, you know, oval shape should be oval shaped, not approximately, not sorta. It has to really be oval shaped. The second part is a deficiency in BI-RADS. For God knows what reason, I was on the BI-RADS committee, but for God knows what reason, we decided to remove the thin echogenic capsule. Catastrophic, terrible mistake. Circumscribed margins without a thin capsule do not have a good enough negative predictive value. You really have to look for that thin echogenic capsule, and I hope we come to our senses in the next version of BI-RADS and put the thin echogenic capsule or thin hyperechoic capsule back in. And furthermore, it's not enough to have a thin capsule on the front and the back of the nodule. You have to very carefully search out for the capsule on the sides of the lesion, because the sides of the lesion is where invasion occurs. The coronal plane is the path to low resistance, and the coronal plane is on the sides of the lesion. And the third thing is that our training underemphasizes the hyperechoic elements. You know, we're taught hypoechoic, hypoechoic, hypoechoic from morning till night. And the best predictive value for cancer versus benign is not the hypoechoic part. It's the hyperechoic thin capsule, the hyperechoic echogenic rim, and the hyperechoic spiculations that give us the best predictive value. So, you know, readers did not recognize the hyperechoic elements because our training is terrible. Our training is that we should only look for the dark parts. Wrong, wrong, wrong. The last thing is that unless radiologists scan themselves, they're often given two views through the widest part of the lesion by their sonographers. And so what we found is that orthogonal video sweeps, starting in the soft tissue on one side of the nodule and going across to the other, showed the answer where the still images obtained by the sonographer did not. So I'm a big advocate of, if you're not actually doing the scan yourself, you should be looking at video loops, not still images. So all of these are things that in ACR BI-RADS can appropriately be considered oval-shaped. In the first version of BI-RADS ultrasound, which was edition 4, we separated macrolobulated from oval-shaped. In edition 5, we decided to include macrolobulated together with oval-shaped. So whether it's macrolobulated or oval-shaped, you can classify it as oval. So on the top are what I call flat oval. What do I mean flat oval? If I take the maximum diameter in the horizontal plane and divide it by the maximum AP dimension, the ratio is greater than 2 to 1. The bottom are all macrolobulated lesions that can be considered oval, but the two on the right, number 5 and number 6, would be plump oval because the ratio of maximum diameter to AP is less than 2. And I'll show you why that's important later. But all of these, even though they're macrolobulated, can appropriately be considered oval-shaped in BI-RADS edition 5. Is this a problem? I don't think so. I'm okay with what we did there. Now, what's really important is a mass roughly or strictly oval-shaped. And here's where the consistency and reproducibility fell off dramatically. Readers varied greatly in what they would classify as oval-shaped. And this was a major contributor to false negative classifications. So triple negatives in particular, and mucinous carcinomas in particular, and papillary carcinomas in particular, can be oval-shaped and circumscribed. So let me show you a case. False negative case 1. Absolute false negative, meaning that readers called this BI-RADS 3 when it was malignant. So here's the orthogonal views of the mass. All 7 readers and I called the shape oval. Now, I don't know what I was thinking. I must have been smoking dope or something, because when I look at this, there's no way it should be called oval. First of all, oval shape should have a parallel orientation. If it's non-parallel, you can't call it oval. So clearly you can see on this radial view that this is not parallel. But you can also see when I draw in the region of interest around this, even in the anti-radial view, I was just sloppy. The 7 readers were sloppy. We all kind of blew it. We shouldn't have called this oval shape at all. Now here's a video loop. This is a long axis video loop. And notice the hyperechoic spiculations. I mean, the readers just flat didn't see that. This is not an oval shape. You can see that when I draw the region of interest, this is highly irregular. It has a thin capsule on front, it has a thin capsule on the back, but it has a thick, ill-defined echogenic rim on the ends, and it has hyperechoic peripheral zone spicules. So I mean, there's a lot there that's not reassuring. This is a short axis view, and this is a still image from the short axis video sweep. SAX stands for short axis video sweep. So what I'm doing is scanning across the lesion in the short axis of the transducer, starting outside in the surrounding tissues on one side and going all the way through to the outside tissues on the other side. Notice that it has a thin capsule in the front and back, but it does not have a thin capsule on the ends. And this is what I'm saying. If you're going to call something a thin capsule, it should be completely surrounded. The path of low resistance for invasion is between the tissue planes. Where is between the tissue planes? In the coronal plane. Where's the coronal plane? On the sides of the lesion. So many of these false negatives actually were quite scary looking on the sides of the lesion, but falsely reassuring on the front and back. So the front and back don't have the answer. The answer is on the ends of the lesion. What's the problem there? Well, axial resolution of ultrasound is about 100 microns. Lateral resolution of ultrasound is 500 to 1,000 microns. So we have much better resolution of the capsule in the front and back because that requires axial resolution at high frequency. Whereas showing the capsule on the sides requires a lateral resolution, which is lower. And also we have critical angle phenomena. As the beam comes down, it reflects and refracts off these sides. So we actually have to manipulate the probe. We have to use spatial compounding. We have to do whatever trick we have available to try to show the capsule on the ends as well as possible. But again, this is showing a nice capsule on front and back, but a thick, ill-defined echogenic rim on the ends. And actually, if you look, you can see alternating white and black lines. So there's hyperechoic and alternating hypoechoic spiculations, as well as peripheral zone hyperechoic spiculation. So in my scoring system, these are all pretty high scores. Even if you call it plump oval, there's other features that should prevent the false negative. So if I plug this into my artificial intelligence, actually this is not artificial, this is just a polynomial regression equation, but I have a polynomial where I can plug in these scores and predict the likelihood of malignancy. You can see my likelihood of malignancy here is 96%. Anything over 95 is BI-RADS 5. So it was called BI-RADS 3 by all the readers and myself. In retrospect, using the video and my regression equation is really a BI-RADS 5. There's no way we should have called this BI-RADS 3. Now, these scores that I put in yellow, let's start with a shape score. 0 score is flat oval. So of the 7 readers, 5 called it flat oval, 2 called it plump oval. So gross overuse of the oval shape. And I was in there, I called it flat oval too, so I made the same mistake the readers made. Now if we look at the peripheral zone, 0 means no spicules, 1 just means some artifactual shadowing. So 7 out of 7 readers didn't see the hyperechoic spicules. Now what about the thin capsule? Well, 0 means they saw a complete thin capsule. So 2 readers said they saw a complete thin capsule. 1 means they saw the capsule on front and back, but not on the ends. 2 means it was circumscribed, but they didn't see any capsule. So 4 of the 7 readers really didn't see the capsule. So basically, there were a lot of mistakes made there. This was a grade 2, ER positive, PR positive, HER2 negative, luminal B cancer with a Ki-67 to 39%. It's a bit unusual for a luminal B to fake you out. Usually it's going to be a triple negative or a mucinous that's going to fake us out, but in this case it was a luminal B that we underclassified. Now, I'll say the same thing for round as oval. Approximately round is not round, it's irregular. So we want to be strict in our definition of what's round and not. Here are my PPVs for round. And when I compare with the readers, theirs was twice that, it was 40-some%. So they were calling stuff round, I was calling irregular. So here's a lesion I called irregular that a lot of readers called round. Notice how hypervascular it is. Notice that it's stiff and the area of stiffness goes outside the hypoechoic central nidus into the echogenic rim. Notice that it has a thin capsule on front and back, but it actually has a thick echogenic rim on the right side and on the left side as well. And it's, you know, there are some microlobulations there. I mean, this is not round. So now let's talk about what I think is a deficiency in BI-RADS that we need to fix in the next version. BI-RADS just used circumscribed margins. I created a scoring system where I took circumscribed margins and I created 4 subcategories of circumscribed. So a score of 2 is the current ACR BI-RADS definition. The margins are circumscribed, but I can't see a thin echogenic capsule. A score of 0, I see a thin hyperechoic capsule on the front and on the back, but also on both sides. So that's a score of 0. I have a complete thin capsule all the way around. A score of 1 is I see a beautiful capsule in front, I see a beautiful capsule on back, but I can't really identify it on the sides of the lesion. The score of 2 is I have a well-defined echogenic capsule, but it's a little thicker than normal. Usually these are post-inflammatory, but occasionally they can represent cancer. So basically, the current ACR definition is all the way up at 2. I've got 3 scores that have lower likelihood of malignancy than the current ACR classification. So let's look at a second case now, specifically looking at capsule. So here's a mammogram with a mass, and we can see that on one view the mass is completely circumscribed, on the other view it's either obscured or partially indistinct. It's kind of hard to tell, but the ultrasound is really pretty reassuring. Most people call that flat oval shape, and it's got a ratio of 2 to 1, exactly 2 to 1. Again, these are from video sweeps, and they look pretty reassuring. Enhanced through transmission, oval shape. But we're going to look at this more carefully now as I go through the video. Also, the Doppler is positive. Again, you can't trust the negative Doppler, but this is way more vascular than I would expect a fibroadenoma to be. This is going to be a papillary lesion or cancer. So the Doppler, I don't think you can downgrade with a Doppler. I never trust the negative Doppler, but I can certainly use a Doppler to upgrade. So let's load the videotape. Here's what I want you to see. Is this spicule, or is this a normal tissue plane? The answer is I don't know, but to have it cut off like that, that's not a good finding. If this were a benign tissue plane, it would be continuous with the anterior capsule or the posterior capsule. When you see a tissue plane chopped off like that, that means there's an invasive cancer there. Again, beautiful anterior, beautiful posterior capsule, a little bit of a thick echogenic halo on the right, and just kind of microlobulation and maybe even some angles on the left side. Again, same thing here. Notice that that tissue plane is completely cut off. That's just not a reassuring finding. And again, even though the capsule is beautifully thin and well circumscribed in the front and back, it's a little thick and ill-defined on the sides. Now also notice that I've got some hypercoax spicules in the boundary zone. So not only do I have a thick echogenic boundary zone on the sides of the lesion, despite the thin capsule on the front and back, I've got frank, short boundary zone hypercoax spicules. Again, I want to show you the tissue plane cut off. Nice thin capsule front, thin capsule on back shown by the green arrows, thick ill-defined capsule shown by the pink arrows on the side. Again, if I feed this through my regression equation, and again, this is a frame taken from the video, look, clearly that's not oval shaped. And clearly, in this particular case, do I have a partial thin capsule on front? Yes. Do you have a partial thin capsule on back? Yes. But what do I also have? A thick echogenic rim and boundary zone spicules. So in ultrasound, if we have a mixture of reassuring and suspicious findings, we always go with the more suspicious finding. So would I say this is a partial thin capsule? No. I would say that this is either a thick echogenic rim or frank boundary zone spicules. I have to go with the more suspicious finding. Would I call, there's a roughly oval shape, but there's angles. So am I going to say this is irregular with angles, or am I going to say it's oval shaped? I'm going to say it's irregular with angles. This is going to be very similar to the other case. Once I plug this into my regression equation, I'm going to get a BI-RADS 5 likelihood of malignancy. I mean, greater than 95, or 95 or greater is BI-RADS 5, not 4A. So what we're seeing again is the same three things over and over. Overuse of the oval shape, inadequate recognition of the thin echogenic capsule, and complete blindness to the hypercoax spicules. Nobody's looking in the surrounding tissues. If I go back and draw this line, okay, I typically draw two regions of interest. I don't think you need to do this forever, but it's good training. This is the internal zone, and this is all that BI-RADS looks at right now. because they took away the boundary zone, they don't look at the boundary zone. So internal zone is inside the white line. Boundary zone lies between the aqua and white lines. And peripheral zone lies outside the aqua lines. Everybody's blind to the peripheral zone. I mean, the best way to see these spicules is a short axis video sweep. You can see these hypercoax spicules pulling in and going out, retracting in and going out as you sweep across the lesion back and forth. If you put your video loop into a sweep back and forth mode, it becomes very apparent. It's much more apparent than on any still image. And the yellow lines are showing the hypercoax spiculations. This was a grade 3, ER/PR negative, HER2 negative, triple negative cancer with a Ki-67 of 60. This is what we expect. So this was a case that had a large biologic component. We know that biologically triple negatives are more likely to fool us. But you can see that by storing video loops and carefully looking at the frames as we swept through it, I could correctly call this BI-RADS 5. But the two still images that I originally showed you, they look falsely reassuring. And this again is a reason that I've become a big advocate of storing radial and anti-radial short axis video sweeps through the lesion and doing my reading from them instead of two still images. Now, this is showing you that no single feature can achieve a false negative rate of less than 2%. So for the readers, the best they could do with flat oval was 6.6% false negative rate. The best they could do with a complete thin capsule was 3%. If our goal is 2% or less false negatives, boom, we fail with single features. What this shows is only by combining a truly oval shape with a complete thin capsule can I arrive successfully at less than a 2% false negative rate. The complete thin capsule alone doesn't do it. Partial thin capsule doesn't do it. Or partial thin capsule plus a flat oval shape doesn't do it. Only the combination of the thin capsule and flat oval shape achieved the desired false negative rate of less than 2%. Now what this shows is that margin alone just completely bombs out. So this is a circumscribed alone, 22% false negative, mid 4B. Circumscribed plus flat oval, low 4B. It doesn't even achieve 4A. So the ACR definition of a benign margin circumscribed is woefully inadequate. Ignore it, look for the thin echogenic capsule, and hopefully we can get it fixed in the next edition of BI-RADS. Circumscribed plus plump oval back in that mid 4B range, and round plus circumscribed, sort of upper mid 4B range. Clearly, circumscribed with any combination of shape totally fails to define any population with less than a 2% false negative rate. So in summary, ultrasound studies are more likely to be classified as oval-shaped, especially plump oval, than our true positive exams. Part of that is biology, especially because grade 3 and triple negatives and some mucinous and papillaries may look that way. But I think the biggest component is interpretive error. People are way too loose on what they call oval-shaped. Roughly oval is really irregular and should be called irregular. It has to be strictly regular. The radiologists really were not looking at the sides of the lesion. Invasion occurs in the path of low resistance. Where is that low resistance? On the sides of the lesion. Is it on the front of the lesion? No. Because you'd have to go through tissue planes to make the front irregular. Is it on the back of the lesion? No. Because again, you'd have to go through tissue planes in order to create irregularity on the back end. Where does irregularity occur? Where there's low resistance to invasion. Where is there low resistance to invasion? Between tissue planes. Where do we see the reflection of between tissue planes on a breast mass? On the sides. Still images don't give us an adequate view of the sides of the lesion. Video sweeps give us a much better appreciation, and you want spatial compounding and some healing and towing of the probe to try to actually fill in the thin capsule on the sides of the lesion. The other thing is, radiologists just are failing to see the white parts of the lesion. We've been told for years, look at the dark part. It's all the answers in the dark part. Baloney. That is fallacious. The white parts of the lesion are far more predictive of whether it's benign or malignant than the dark parts of the lesion. You have to train yourself to look for the white parts of the lesion, not inside the lesion, but in the boundary zone and in the surrounding tissues in what I call the peripheral zone. And the ACR current descriptor of circumscribed margins is woefully inadequate. We need to add the thin capsule and the thick echogenic rim back into our lexicon. Thank you.